Alright, we're going to look at the very basic secant function graph, namely the most standard secant function y equals secant of x. And what we're going to do is use the fact that this is the reciprocal of our very standard cosine of x function. Okay, so the y values of the secant function will be the reciprocals of the y values of our cosine function. So let's get started here. So the first thing I will do is in blue I will graph the cosine function, and we know that cosine goes through a full cycle as the angle x ranges from 0 to 2 pi. So here's 0, here's 2 pi, and we also know that cosine ranges from -1 to 1. So I'll mark -1 and 1. And so the basic cosine function starts up here at 1 whenever the angle x is 0. And whenever the angle x is 2 pi, you're back at 1. Halfway between, at pi, using symmetry, we're down here at -1. And then halfway between 0 and pi, so at pi over 2, we have to be between 1 and -1, which is 0. We do the same thing over here, which would be 3 pi over 2. So our cosine function looks like this. On this particular interval. So we're going to look at secant of x and cosine of x between 0 and 2 pi, because that's a full period, and then we'll just use the fact that that's a period and repeat the pattern both ways forever to get the rest of the graph. So so now to graph secant, we will look at the reciprocals of these y values. So for example, at this point, the y value is 1. Secant's y value will be the reciprocal of 1, which is also 1. So it stays right there. Okay? So that's the same thing over here at this point. I'm going to graph secant in black. Now, down here, cosine is -1. The reciprocal of -1 is -1, so secant's also going to hit that point. Now, this is a bit more interesting. At pi over 2, cosine's y value is 0. Well, the reciprocal of 0 is undefined. So what that means is we're not actually going to get a point for the secant graph whenever x is pi over 2. And that's also true for when x is 3 pi over 2. So we'll have to sort of see what happens there. So now what we do then, since we know that cosine, we know all of these cosine values here, and we know secant's undefined at this point, let's look at what happens between this black point up here for secant and this point down here where secant's not defined. Look at the y values on the cosine function. They start at 1, but then they're getting smaller, right? They're getting closer and closer down here to 0. Well, imagine as I get really close to 0 here, the y value is really close to 0 for the cosine function. So secant would be the reciprocal of this really small number. Say this y value is 0.01 down here, just as an example. The reciprocal of 0.01 is 100. So at this x value, cosine has a y value of 0.01. Secant's going to have a y value of 100, way up here. Okay? So the idea is when you take the reciprocal of numbers smaller than 1, you get a number bigger than 1. And as I keep getting close to 0 here, 0.001 is also closer to 0. Its reciprocal will be 1,000. So what ends up happening is at pi over 2, secant has this vertical asymptote. I can't touch this asymptote because we already know at pi over 2 secant's undefined. But as my x values get close to pi over 2, the cosine y values get close to 0, which means my secant y values get really big. In other words, they approach infinity. So as my x values get close to pi over 2 on this side, my y values are getting really big, and there's no limit on how big they get because I can get as close to 0 down here for cosine as I want. And that's also true over here. at 3 pi over 2, we can see the y values are getting close to 0 for cosine, so my secant values are going to get close to infinity or get really big. And that's also true right here. My y values are getting close to 0, but these y values are negative now. You see that? They're below the x-axis. So the y values for my secant are really big numbers again, but they're really big negative numbers. So my secant graph is going to do this, and similarly on this side it's going to do this. So the black portion here is my secant graph, and that's one complete period this pattern repeats. So notice the left side of this period is sort of half of an upward U. So if I were to continue my graph over here, I would start my next period with that region, and it would look like this. And then I'd have another asymptote right here. And then I'd come down, and I'd have a downward U in the next region, another asymptote, and it would repeat. So what it ends up being is, if I continue this pattern left and right forever, is a bunch of upward and downward U shapes. And that is the basic secant function graph based on the cosine graph from 0 to 2 pi.